Actually, I find it quite calming. You might find that surprising. I think the fact of how they survive as an entity, they all have their individual roles, but they're all in it for the good of the colony. They're just marvellous, really, in how they adapt and how they survive. It's not been as easy as I thought it would be. There's more work involved. Put time into understanding how your bees are behaving, why they're behaving in a certain way, what actions to take. I can see in this frame we've got some eggs, so I know the queen is there, she's laying. As a beekeeper, it's important that you do look after the bees well. They can contract diseases. We've had notification from beekeeping associations that there was European foulbrood prevalent in an area near here, and actually one of our members had his hives infected.
Can you describe what happened?
It's not a pleasant experience having to destroy the colonies, having to do that to the bees. I don't think I can actually. Yeah, it's good drawing it. You've invested a lot of time in the bees, and they're far more than just a colony of bees. So taking the top off and then pouring the petrol in from a very quiet, calm, sleepy, buzzy hive, they just go absolutely ballistic. You put the top back on, the volume is incredible. The sound of them all frantically buzzing around trying to escape. And then they just gradually die. And then it goes quiet. I was on one of my inspections. There's a certain smell to the hives that you just recognise, and something didn't seem right. That was very worrying. So I gave the bee inspectors a call. They came out pretty quickly to have a look. I remember he said on the phone, "What makes you think you've got European foulbrood?" And I said, "Because they've gone gloopy in the bottom of the cells." He said, "We'll be right out." Came out. The guy did a few tests on the larva, confirmed that it was European foulbrood, and the most sensible option was to destroy the colonies. So we just piled it all in there and set fire to it. There's not much left from 2 large colonies of bees, as you can see. So I've got just the 2 hives left now. At some point in the future, the inspector will have to come back and do another inspection just to confirm that the apiary is clear. So he'll be inspecting this one and this one. There are about 250 apiaries within a 3-mile zone of here. So that could be 1,000 colonies, 1,000 hives. So that's why it's so important to make sure that we do clear this up as thoroughly as we can. If we don't do this, then potentially the bacteria could easily spread to those other 1,000 colonies within the zone and then out from there.
European foulbrood is a bacterial infection in honeybees, and the symptoms that are associated with the disease are, on a hive level, it's a foul odor, but on an individual level, if we think about the larvae themselves, we can see how they start from a healthy pearly white color, and then over time they change into a yellowish color, and they start kind of liquefying from the inside out, and then they dry up into a scale. So it's quite disturbing looking, and the problem is that it spreads throughout the hive so quickly. You can just lose entire colonies because of it. It's not really clear when European foulbrood originated, but it's definitely been an issue at least since the 1800s. And it's been recorded at the time as sour brood or black brood. And at the time there wasn't that much of a distinction between European foulbrood or American foulbrood. They were all just perceived as that stinky disease in developing brood. Hey girls.
At Silwood we have quite a number of students looking at bee health. We have PhD student Monica Yordanova. She's exploring what triggers the causal bacteria to turning to European foulbrood. So why do we go from this microbe, which we often found in honeybees, to suddenly become a disease in that bee? And she's working with DEFRA and the beekeeping inspectors to identify when we're finding this in particular hives, and what particular factors seem to be driving that disease versus the microbe to be present in those areas.
The brood are the babies. And this is actually a really nice frame for my experiment because the larvae on it are especially young. Unfortunately, I think we're still a long way away from developing treatments against European foulbrood because there are just still too many unknowns when it comes to understanding the disease itself. So I'm focusing on filling out some of the gaps that remain in our knowledge when it comes to an understanding of the stressors that are increasing the incidence of the disease, but also its transmission as well, how long it can persist in the environment and how it ends up infecting so many individuals. I want to make sure that I'm not taking any of them home. So in here we've got some blocks that have been heated up so that they can thermo regulate what goes inside the box, and that keeps the larvae warm until I get them to the lab.
So I've been keeping bees now for 5 years. I think they're fascinating. You know, the more you get to know about them, it's just incredible how they all work together. All of these you see here are the worker bees. And during this part of the year when they're out foraging, their lifespan will typically be around 4 to 6 weeks. If you look here, see that bee is much bigger? Off he goes. So that's a male bee. You can tell it's much bigger, it's got much bigger eyes up on top of its head. So a bee actually has 5 eyes, 1 on either side. and then 3 on the very top, which is clearer to see on the drones. So that drone just really hangs around, eats the stores, and then we'll go out and mate with the queen when the time is right. Can't remember all the statistics, but so much what we eat is dependent on pollination, and bees can provide that. But so can wasps and other insects as well, so there should be an equal interest in preserving all of our pollinating insects, not just the honeybees.
I've been interested in insects for a long time. When I was a child, I loved insects, and I came to museums like the Natural History Museum, and I was really inspired by the collections here. So this is the Natural History Museum here in Oxford University's British bee collection, and it's a collection of every species of bee in the UK. Bee species are under threat because of the way that we're managing land, the use of pesticides on the crops that we have, climate change, and bee disease. All of these things are having impacts on bee species. This particular drawer has a collection of the Andrenidae and the Halictidae. They are the mining bees, and they are a solitary group. And you can see that this is a very diverse group. In fact, most of the species of British bees, of the 250 which are found in the UK, are these solitary bee species. And they're very important pollinators of many crops. Andrena lathyri has gone extinct, and that's because these bees primarily live in the springtime. And in winter and in late autumn and late summer, they are living underground. So if the climate never gets very cold, then what happens is their metabolism remains at a high rate, and they use up all of the food stores that they have in their body, so they're likely to die. Another group are the bumblebees. They're beautiful, big, hairy bees that you might see in your garden. But these bees, they are eusocial bees. They live in colonies, and they are also sensitive to habitat disruption and to climate change. And in fact, Bombus lapidarius is one of my favorite bee species. It's a very large black bumblebee with a bright orange-red abdomen. And we know that in the past 10 years, in fact, that populations of Bombus lapidarius have been declining. Bombus pomorum was a species that went extinct in the 19th century. We have one example of that bee, and it's really a reason why we have these collections is to keep a record of things that were here before and that we may have lost. So when people think about bees, they tend to think about honeybees, and this is an example of honeybees that were collected in the 19th century. And you can see they're relatively smaller than bumblebees. It's only recently that we know that there is spillover from the honeybee to other species like bumblebees. It's work that was funded in the UK and also through the EU of scientists here in the UK who are interested in bee disease.
You can have populations which have the disease and populations which don't have the disease. And when you get a transference of the disease from one to the other, we call that a spillover event. So if we look at the health of bees as a community, so not just in one particular species, across all species, we find that the levels of disease that we find in those populations is linked quite heavily to the levels of disease in the local honeybee populations. So when we look at the health of bees, we often have them on red light in the lab, and that's because bees can't see red, and so it allows us to be able to see the bees without stressing them out because they feel that they're still in darkness. And so the room that we're about to go in is likely to be under red light. It's been shown that the declines in bee populations have been due to multiple factors, and so those factors tend to be climate change and also the use of pesticides. So these are small bumblebee colonies, and so you'll see that there's a little cluster of eggs, which is unlike you're seeing like a honeybee hive, for example. And by being able to look into the hives like this, we're able to see how pesticides influence bees, but how that may interact with a warming climate. In fact, multiple bee species are under threat, primarily because most bee species are solitary. So if you imagine 5 particular solitary bees, there are 5 mouths competing for, say, 100 flowers in that area. If you put a single honeybee hive in that area with a single queen, there could be then 50,000 workers. So that one queen has 50,000 mouths to compete with the other 5 local native bees in that area. Yeah, so honeybees will dominate an area when they're there, just because of their numbers. There's so many, and they're, unlike other bee species, honeybees forage not just for that day, they're foraging to collect honey to get them through their entire winter, whereas other bee species will hibernate over winter, so they don't need to have this store. And so that's why honeybees are honeybees. They're collecting this honey to get them through hibernation, and then beekeepers then will harvest that honey because honeybees have been selectively bred so that they produce more honey than they need, and that's kind of how the system's set up, really.
So off to the apiary at the church to start the extraction process. So the first step being to get the supers, which are full of honey, off of the hives. So hopefully the bees will cooperate, taking all their food away. Then we'll take all the supers, put them in the car and bring them back to the house. And tomorrow we'll start extracting the honey. Heavy load. So make sure we've got space for another one as well.
I'm just adding feed into the tissue plates, so this means that when I'm introducing the larvae into them, they'll be dispensed into food liquid. So this means that they'll also have enough nutrition that they require for their development.
This is quite a nice even frame. Sometimes when they're bumpy it's very difficult with this tool to uncap. So this is taking all the cappings off and using this uncapping fork to do that. There's various ways you can do it. Some people will use a hot knife, some people will use an air gun, a heat gun. I just find this to be most suitable for me. So that the cappings are the product of the wax that's secreted by the bees. They have wax glands on them. So that's them getting ready to store the honey so they can use it over the winter. Without getting the cappings off, when we put it into the extractor, the honey would just stay inside of the frame. So once this frame then goes into the extractor with the cappings off, the force of the extractor spinning around will force all of that honey out into the bucket and down to the bottom.
But yeah, now I'm just selecting nice young larvae and just gently grabbing them from the back. And they're extremely vulnerable, so it's very important to be very careful with this part. And then I'm just floating it on top of the food, which is not a bad way to live your life. In the next stage of the experiment, I'll be looking at how these larvae develop over time and how they're going to be affected by the stressors that I introduce to them. I can introduce certain pathogens into the feed at a certain concentration that I want them to be exposed to, and I hope that in the future we can also explore some potential treatment options. So for example, certain probiotic treatments or other options that might reduce the incidence of the disease and the other stressors that it interacts with.
One of the nice things about having your own honey is that you can obviously utilise what you've harvested, and what we do is we keep a small jar of the honey we produce every year as a sample to look back on, which I've got over here. It's interesting to see in the different samples the different colours and textures of the honey that the bees were collecting. So obviously some very different forage in the first year from what followed through to last year, and I entered into the association's honey show and was lucky enough last year to win the prize for best set honey. And then what I have over here is just a sample of what we harvested this year. So you see a very light golden colour, but quite different from what we had last year, which is interesting. Obviously, one of the perks of keeping bees is that you have a never-ending supply, hopefully, of some very tasty honey.
Domesticated honeybees are important for honey production. In addition, people are trying to keep them in larger populations because of the demand for pollination. Diana, hi Leah. Are all these bees from the Karnika colony?
They are, yeah.
They seem healthy?
I think so.
Good. My lab is interested in trying to understand how nutrients in bee colony diet influence their susceptibility to pathogens and parasites. And that includes bacteria like European foulbrood or viruses like deformed wing virus. And this is because we know that malnutrition leads to dysfunction of the immune system. Yeah, it's a new colony, I guess, huh?
Yeah, well, it's just about entering month 2, so that's like the kind of boom period. They'll probably be good for a month. It means that when we get to the robbery stuff, and I think I can reuse the bees.
There aren't
that I've used for
preventative
this,
treatments
stuff like that.
against European foulbrood or against deformed wing virus because beekeeping is, relative to other industries, just not as well financed. And because we're not eating bees, we're not investing as much money in them, the research on these things has lagged behind. We hope that by improving the nutrition of bees that we'll be able to stop or help to mitigate against the very severe types of pathogens or pests that are afflicting bees now. But in the meantime, it's a terrible shame that whenever a colony gets European foulbrood, we have to burn the entire colony, and it's really horrible actually to have to kill a whole colony just because there's a small infection within that colony, which will rapidly spread to an entire apiary and destroy them eventually.
I am quite worried about the inspection because you just don't know if you've got rid of it all or not. We'll just have to wait and see. Which one you want to do first?
So what's the outcome?
That all went well. Clearly they don't have the European foulbrood, which is a big relief. Yeah, so I can relax a bit more now.
It's very important if you're a hobbyist to take this hobby extremely seriously. The problem is that if a lot of people just keep a hive in the backyard and they don't take care of it, what they do is they actually place a higher demand on the nectar and pollen in their surroundings, and that reduces the forage that's available for native pollinators. So ironically, someone who might be wanting to keep pollinators thinking that they're doing something good for the environment and for biodiversity is actually causing harm. There is hope for the future, and I'm certain that science will be the way that we can develop technologies that can vaccinate bee colonies and be able to stop these global pandemics within bee populations, which are currently actually causing quite a lot of damage to both managed and wild bee species. We don't know what a world without bees would look like. We depend on them so much that it's very likely that food supplies would dwindle a lot. We would lose native plant species over time. It's really important that people are more in touch with the natural world because we depend on the natural world. It's easy in an urban environment to be divorced from it, to not see it and understand where your food comes from and how much even the oxygen that you breathe is a result of the nature that you cohabit the earth with. I do hope that at least maybe the people in your generation will take this more seriously and really care enough to stop the erosion of biodiversity. And you have a chance still, but the time is growing shorter and we really need to care or it'll be too late.